Earlier today, I did this exact problem where we talked about using half reactions to balance equations in acidic solutions. Well, it was a lot going on that problem, so I'm actually going to redo it, okay? And I'm going to go slow. And if you have questions, I want you to make sure you ask them. And better yet, as I'm doing the problems, you can do it along with me. But make sure you pause for the cause if you want to digest the information, okay? So make sure that if you're going through this problem with me and you don't quite understand what I'm doing, make sure you pause the screen and come back to it, okay? Let's go ahead and get into it. So you've got iodine, aqueous solution, plus chromium. You actually have a dichromate in aqueous solution that produces iodine 2 solid plus chromate ion, aqueous solution. What you have to do is separate the iodine first, okay? So right now we see that there's an iodine with a -1 charge that yields iodine 2 in the solid form. Then we have the dichromate ion, and it's going to yield just simply the chromate 3+ charge ion. So what we're going to do, we're going to first try to balance the iodine. And what you have here is that you have 1 iodine on the left, 2 on the right. So I'm going to put this iodine reaction in parentheses, put a 2 on the outside that tells me I'm going to multiply that 2 times the iodine with the negative charge. And this is going to give me over here 2 iodine with a negative charge, aqueous, and that's going to produce just simply the I2 subscript of 2 in the solid form. Now, you don't let that 2 carry over to the iodine with the subscript of 2, because if you do that, here's what you're going to end up with. If I say 2 times basically that 1/2, your 2's are going to cancel out and you'll end up with 1. That means you're going to have just 1 iodine. And then you're going to have to start all over again, trying to make sure they're equal on both sides. So the coefficient of 2 iodines in front is the same thing as iodine with the subscript of 2 on the other side. Now, we're going to do the same thing for chromate, meaning we have 2 chromates on the left, but we have 1 on the right. So what are we going to do? We're going to actually multiply that particular reaction also by 2 to make sure that we can balance that one out. But we're going to multiply the 2 times the chromate right here, okay? Again, the same thing holds true for the Cr2O7, meaning that if we make that 2 go to the dichromate ion, that's going to cancel out your chromates, and you're going to end up with 1 chromate on the left. So that 2 is only for the Cr with the 3+ charge. And this is what you end up with now. Cr2O7 with the -2 charge, aqueous, that produces or yields 2 Cr with the 3+ 2 Cr with the +3 charge, aqueous. And now we're going to pull all that information down and begin to balance our oxygens next. Simply put, I have 7 oxygens on the left-hand side, but I don't have any on the right-hand side. So in order to balance the right-hand side with what's going on the left-hand side, you're going to now add water molecules to the right. Watch what I do as I do that next step. So I'm going to actually pull down the reactions so that you guys can see everything in a cleaner format, okay? So watch what I do. Pause the screen if necessary so that you can grasp this concept. Now, in this case, because we have 7 oxygens on the left, we're going to have to add H2O, yes, liquid form, but we're going to add 7 right there to to verify or illustrate the 7 oxygens from the left side that needs to equal to the 7 on the right side. Now, as a result, that means we're going to include hydrogens. But before we get to hydrogen, let's go ahead and watch what happens when we balance out our hydrogens. We have 14 hydrogens on the right-hand side as a result of us trying to balance out our oxygens. So let me show you what I mean by that, okay? So right here, we have 7 times 2 for your hydrogens that gives you 14. So what we're going to have to do on the reactant side, we're going to have to add 14 hydrogens with a plus charge, aqueous. So I'm going to rewrite that out. So again, it doesn't look so messy. So watch what I do. Move on to the next step. Now, when you get to this next step, you've got to now balance off your charges, your electrons. Anytime you have extra electrons hanging around, you've got to take care of those, okay? So how do we do that? Stay tuned. So now, as you can see, there are 6 electrons. Because of the 2 times the 3 plus charge for chromate, you end up with 6 electrons. And what we should have placed in this step here, so that you guys can see that, is whenever you have the 2 iodines here, you also had to have a +2 for your electrons for iodine. Now, what am I talking about? Well, remember how we discussed anodes and cathodes, oxidation and reduction reactions, and how if you start off with the 2 iodine here for your charge of your iodine, you're going to have to also add 2 electrons. That's going to give you your iodine solid. Same thing for the dichromate ion. We have Cr2O7 with a -2 charge. That's going to produce the 2 Cr3 plus charge for your chromates. Now, when we add the 6 electrons here on that side, this simply means that in order to balance out the right-hand side with the left-hand side, what we're going to have to do is to multiply this particular reaction here by 3, the coefficient of 3. And you're probably wondering why? Because we need to balance out our what? Electrons, okay? So I'm going to put the whole thing in parentheses, but here's what's going to happen. That 3 is going to get multiplied times that 2 for iodine. That 3 is going to get multiplied times that 2 for the electrons. And guess what else? That 3 will also get multiplied times the iodine in order to make sure that everything is equal, okay? And we cannot forget about everything else that we have going on here as well. So I'm going to actually pull those 2 together, and I'm going to show you what we're going to end up with now. So this reaction here is going to give us 6 iodines with a negative charge plus 6 electrons. That yields 3 iodines as well. Now, I know I've been forgetting to place my physical states, but I'm doing it right here. And the reason I've been forgetting to place the physical states is because it's taking up a lot of space as I write. But you want to make sure that you still be consistently doing them across the board, okay? So I'm going to rewrite this equation again, okay? And you're going to see the new information down below, all right? So we're not going to touch this bottom one just yet, okay? Because we've already taken care of the bottom one in terms of the 6 electrons that we have. So what am I going to do? This new reaction here is going to replace this part right there. Okay, we're still going to add our 14 electrons. Our 14 hydrogens. We're not going to forget that part. So let's go ahead and rewrite our equation once more. So we're going to write 6 iodines, solid form, plus 6 electrons, okay, plus 14 hydrogens, plus that dichromate ion, okay? Again, we're just going back, repeating what we had previously up here, okay? That produces the iodine here of the 3 iodines plus your chromate, the 2 Cr with the 3 plus charge, plus your 6 electrons, plus your 7 water molecules. I know that's a lot. These types of reactions can take up a lot of paper, okay? But hey, that's the name of oxidation reduction reactions, okay? So now, what are we going to do next? We're going to go ahead and cross out things that no longer serve us. Also keep in mind that this is a repeat of oxidation and reduction problems. If you don't recall oxidation and reduction problems, hit that link up there and it'll take you straight to further examples like this. Okay, so let's get back to this part. So now what are we going to do? We're going to cross out things. And also, guys, this reminds us of net ionic equations. Net ionic equations, they're quite similar. So what are we going to do next? We're going to cross out things that we don't need anymore. Whatever's on the left is also what's on the right. If they look identical, snip, 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 cross them out. And what are we going to cross out in this particular example? We're going to cross out the electrons. 6 electrons on the left, 6 electrons on the right. And now we're going to write down what remains. So here it is again. 6 iodines plus 14 hydrogens plus the dichromate ion that yields your 3 times your 2 for your 6 iodines plus your 2 chromate ions plus your water molecule. And there you have it. This is your final balanced equation for acidic solutions. Stay tuned because in the next video, we're going to do one where they're basic solutions. How are they different from acidic solutions? Keep watching and you're going to find out how. Thank you so much for watching this video. If this video served a great purpose for you, make sure you hit the like button. We don't ask for anything more other than hit the like button and tell a friend to tell a friend to tell another friend that, hey, Professor TK the Chemist goes live every day, 12 noon Eastern Standard Time on Tickety Talk Talk and YouTube. Okay? Have a good one.